Okay, we're back, and it's COMP100, week 5 equivalent, right? Lesson 5, part 1. We're going to be talking about decisions today, how to do if statements properly and all that kind of business. But before we get into that, I want to go over and review what we talked about last week a little bit, and the week before, actually, because I think it's a good opportunity to do that. Take a look at assignment number 1 and talk about who's having difficulties with it. What are the difficulties? What can we do? And let's go over kind of some solutions for what assignment 1 should look like. So let's go over last week, we talked about using data. So just as a recap for those people who were here, right? When we did using data from chapter 2, right? We talked about values, variable values, how to set up variables, different data types. So we had floating point data types, Boolean data types, different ways of type conversion, strings, all those kind of stuff. And we also talked about, we didn't get a chance to talk about named constants and enumerations, which I wanted to kind of go over today, right? So we talked about some basic things. There are some basic things around constants. I kind of glossed over that piece. But again, if you remember the data types, there's a bunch of different ones that we talked about last week with different lengths. Byte int is the most common one, which is of a system type int32, right? We also talked, the other common ones are float. You're going to see that being used a lot, which is single precision floating point, like decimal, basically like a single precision. Then there's double precision floating point, which is the double. Those are also common, and decimal. Decimal you probably won't use unless we're doing some kind of calculation that requires some kind of scientific calculation. And in this class, we won't be using probably decimal or even double. Probably mostly using float, okay? Because that's kind of a decimal. The other ones are equivalent in terms of the way they operate. It's just that they have additional accuracy when it comes to floating point or fixed point precision. Okay. The character, the char or char, is a single character that takes in one character at a time. Boolean type, of course, is a true or false value. So it's either like a 0 or 1 equivalent, true or false. So that's 1 or 0. And then there's the string type that takes, basically a bunch of little characters strung together. That's what's called a string. That can form words. So we know them. We look at them and we look at them and say, well, this is a word, but really it's just a bunch of characters put together. From an English perspective, when we read it, it reads like a word. But from a computer perspective, it just sees a bunch of characters strung together, right? That's why it's called a string. So those are the basic types that we looked at last week, and how to operate with them. How to use the equals operator to kind of assign a literal value. This is the literal value to a string. To a string variable. And remember, what variables is a friendly name for a memory location where we can store our values. Right? So this is a double. We made some examples just going through here. We also understood how to format our output, where we use a placeholder, also called string interpolation, a way of taking our variable and replacing wherever the placeholder is, swapping out the placeholder with the variable name, like just swapping that out, right? We talked about that. We also talked about how we can do this in terms of our string format, how we can format the output. We tried this last week as well. And we got into things like different types of floating point numbers and how behind the floating point number we need to use the F, D, or M digits, right? To kind of denote whether it's going to be a floating point, a double, or a decimal with the M. So F, D, and M. And we use that because the compiler, C# doesn't know when you take a literal, like for example 0.01, how much precision do you want? Normally it defaults to a double precision, right? So if you want to use it, you want to put a 0.01, you put that into a floating point number, then you need to let them know, the compiler know that it's a floating point you put an F for a floating point. And this is the codes that you can use to describe. We talked about operator precedence really easily, and it's the same as in math, where, again, you have to think about multiplication, division, like that whole BEDMAS idea, brackets first, exponents, division, multiplication, addition and subtraction, just the way we do stuff in math, is the same way that the computer will kind of use operator precedence. Right? So look at those things and go, well, if I see a multiply and I see a plus, like an asterisk and a plus, I'm going to do the asterisk, perform that calculation first, and then, so the multiplication, and then I'm going to do the addition, right? Because that's operator precedence, just like we normally do in school. Then we also talked about the shortcuts that we can use with arithmetic operations, the plus equals, or bank balance, right? As an examples, when you say bank balance is equal to bank balance, times interest rate, and you can actually use the plus equals to say bank balance plus equals, a value. So you actually add to it. Can I get one of you guys to grab the door for me? Because we don't need to keep that door open anymore. Lots of noise. Thanks. Bank balance plus equals is a shortcut operator that equates to bank balance is equal to bank balance plus something else. Instead of saying that, you just say bank balance plus equals to that. And then it adds whatever the actual value is on top of the original value. We also talked about increment operators, where you can plus some value and some value plus that adds 1 to the value. That's all it does, right? And of course, there's also the decrement operator, which minus removes a value. The Boolean type, where you can use a greater than or less than to compare a value from one value to another, right? And these are the same that we use in school, except for this equals. When you say equal, it's not an assignment operator. It doesn't assign, right, one value to another. It compares two values to make sure they're equal. So remember, the double equals is how you compare to see if a value is equal to something else. And then the exclamation mark equals basically says check to see that it's not equal, right? So we talked about that as well. So these are just the operators. Again, we're just going over the building blocks of our code and how to put all those pieces together. So when we make decisions coming up today, we need to use some of these building blocks, less than, greater than, equals, less than or equal to, and so on, to make decisions. Type conversion, I kind of talked about. There's different ways of doing casting. Like I said, it's called casting. Another way is to talk about type conversion is to cast one data type into another. So we convert, if you will, an integer to a double, or a double to an integer, or a float to a string. Those kind of things. And sometimes you need to do that because we get input from the console. Right? Anytime we get input from the console, it's a string value. And we need to convert this thing, we need to convert it into a float or an integer. And the only way we can do that is we need to use some conversion, kind of a conversion method, which we can use. And we'll talk about that again today to revisit this. We also talk about escape sequences. For example, the \n gives us a new line character. That's a very common one. And also, you can use escape sequences to move up and down and kind of navigate the console a little bit. The string data type, how you can use kind of set these. This is an example of where we set the data type, Amy, and Matthew. Right? These are two names and another name called Matthew, but they're all just strings, a string of characters. To the computer, it doesn't mean anything. The computer can't read Amy or Matthew and decide if it's a word or a name. All it sees is a string of characters that it puts together that are somehow related, that for us humans, we can put them in there and we can read what they mean. But for the computer, it'll store whatever string of characters or numbers we put in there. Right? That's what a string is from a data type perspective. I'm just going to continue on. We can use the length property. This is where I think we stopped last week, where we can use the length property of a string to determine how long it is, right? I think that's what we did here, and I think we stopped right about here. So I'm going to pick it up from here, right, which we're quite along the way. We've got about 10 pages left in this PowerPoint, and then afterwards I'm going to start the other one. Again, don't worry. I want to talk about assignment number 1 and how what strategies you can use to make it go without using if statements. Because up until now, I've given you assignment number 1, but there's no if statements. So let's take a look at assignment number 1. How do we do this one without if statements? Again, it's called using data. Now let's take a look at the first one. Again, I want you to write 5 short programs, which means 5 projects are going to be opened up in Visual Studio, right? So that means 5 zip files. If you don't know how to do these things, we'll do them together today. Let's make 5 zip files, right? And each of these 5 projects, you're going to export, zip, all that kind of stuff, and put up into my Dropbox that I kind of put together for you guys on eCentennial, right? So if you don't know how to do these basic things, we got to learn to do them now, because come second semester, or the next time we get, you guys see programming 2 as an example, these are all things you need to do. Okay. So let's think about the first one. Write a short program to prompt the user to enter a single character. So what am I getting there? 1 character. The program should display a message like, your response was Y, back to the console. All we're doing is parroting back what we get. Get a character, swing it back out. Pretty simple. That one, the easiest one you can do. I'm giving you 3 marks for that if you finish. Second program, you open up a new project, right? New project. Write a short program to ask the user about the validity of a simple statement. This is just the way it's written. It's kind of weird. But all we're asking for here is the program should prompt. I'll even highlight this. Prompt means get data, get an entry from the user, right? A statement, prompt for a statement. That means a string of characters. The user's choice, whatever you want to put in. And accept the response, right? Right? And then display the statement as well as the response. So basically the response could be, the validity means, is it true or false? So what you're entering is true or false, right? It's not going to choose between the 2 things, right? It's not going to tell you if it's true or false, if the statement is true or false. You're going to tell the computer if it's true or false. All you're doing is entering 2 statements. The sky is blue, as an example, right? There's a statement that you put in, and then you put in whether it's true or false. True. And it's going to store that data and parrot it back out to you. So you said the sky was blue, and you said it's true. Okay, here it is. Here's the result. That's what number 2 is about. It's very simple. Okay. Number 3, write a short program to calculate the area of a circle. Okay. And the user is going to enter the radius, which is from the center of the circle to the outside, right, of the circle. That's the radius. And then the program is going to calculate, here's the calculate the area according to this formula. We're going to take, you're going to have 3.14, which is roughly pi, right? And you're going to multiply it by the radius, and then multiply it by the radius again, so radius squared, basically. And the result, you're going to make a result variable, right? The result is going to be displayed to the console. And you must accept fractions, which means you got to use a float for input. Or when you convert the number from, as you enter stuff from the console, you got to convert the number into a floating point number. And we're going to talk about how to convert again if you've forgotten how to do that, right? So calculate. You're going to take numbers from the console and then calculate it. And don't worry about doing validation. Like you're going to assume, we're making some assumptions here, that the user is always going to enter in the perfect amount of data from the console. We're not assuming that the user is going to try and mess you up, right? And enter like characters and numbers and dollar signs or whatever. We're not at that stage yet. All we're doing here is trying to enter some data, converting it from a string into a number, and then making some calculations. That's all you're doing, spitting it back out. That's the number 3, right? Number 4, number 5 are just like number 1, 2, and 3. Let's just go over them. Write a program to calculate and display the potential difference between the ends of a wire. Who cares what it says, right? So here's what you need. You need the current, right, and the resistance. That's what you need. So 2 inputs, right? And the potential difference you're going to calculate as the product multiplication. You're going to multiply current times resistance, and that's going to be your potential difference. That's all it is. Just one times the other one. That's your potential difference, and then you're gonna pull that out as a you're gonna throw that out to the console. Again, very, very simple. You're gonna ask for a couple of values. The user's gonna enter them. You're gonna spit a calculation back out. That's it. Very simple. Here's the last one. Write a program to prompt the user for the amount of adult and child tickets. This is the most difficult one, right? Okay, so I need the amount of, so two requests. How many child tickets do you want? X, whatever. Here they're going to input a number. How many adult tickets do you want? Right? You're going to tell them that it's worth $2.25, huh?
We did something like same as this one.
We almost did that, yeah. Right, but let's just think about this, right? So how many adult tickets, how many children tickets, and then the program will display a user-friendly message to the console of the number of tickets purchased. So you bought 5 tickets, as well as the total cost, with the C, using the C calculation to show that it's currency, right? So you're going to do something like this. You're going to say, I've got 5 adult tickets. They're $3.75. You got to put it in here, and you want 10 child tickets at $2.25. This is how many tickets you ordered, whatever they entered. This is the cost of each one, so adults, children, and here's the subtotal. Pretty simple again. You just got to set up all the variables to set that up. So it's not a difficult exercise, and there's no if statements required. We're not asking for if it's this, then put this. It's not like that. All we're doing is we're asking for input from the console, the user's inputting the data, and then you're immediately calculating and outputting. There's no if statements or any kind of decisions you have to make. Okay. So, and again, these are 5 little exercises. I want to give you a little bit of time to kind of put it together today. If you have something already, you should have already worked on it. I asked you last week, work on it. If you have something, I'll take a look and see what you got. If you don't have anything, that's a bad thing. It means you haven't worked on it at all, and I can't help you out, right? So you need to work on these things beforehand. You can work. I'm not sure if you guys have other classes during the day here. Yes. So you need to come in and do the stuff here on the computers. Make sure that they work. You try this stuff out, and try and make these things go. If you don't know where to start, this is the biggest problem when you're a beginner. You don't know how to start these things. You try and think about, how am I going to write a short program, right? What does it mean by write a short program? Well, there's a couple things you need. Let's do an example of a short program really quickly, and then I'll stop the recording, and then I'll check you out, okay? Anyone else have something to show me today? Okay, if you don't, it's okay. You should. From now on, I want you, when I give you this, the next week I expect you to show it to me, or else I can't help you, right? And that means this first assignment's due Friday, which is like not today, but a couple days from now, by midnight. So you guys should have something going on. If you don't have anything, I can't help you guys. You got to do this. There's a piece that I can meet you halfway, but if you don't know anything, if you don't do anything, I can't help you out. We got to practice this stuff in order for us to get good at it. Or else when you hit programming 2, you're in trouble, right? So in order for us to pass programming 1, you got to do something. Okay, let's take a look. So I'm going to go, let's do this together, right? Go to another machine. Go to this one here. Yeah. Okay, so let's take a look at starting off a new file. So I'm going to go to File, up in Visual Studio, right? New Project. Okay, so let's do this together. So if you're in front of Visual Studio right now, now I know you're trying to load Visual Studio. Just use the machine in front of you for now. Let me know when you're ready to go. Okay? What's the pop-up? Get out of there. Move somewhere else, right? If it's a problem for you, don't waste time with a computer in front of you. Go to another computer, right? I don't want you guys to. This is just system issues in front of you. You should be able to get into Visual Studio and work. If it's giving you a problem, move to another machine. There's like 40 machines in this class. All right? You good? Okay. I'll wait for everyone else. So a new project is what we're waiting for everyone to get. Let me know when you guys are ready. And also, if you miss something and you don't know how to do it, I'm explaining it here in class, but I'm also putting it up on the videos. So you have like, guys, almost 4 hours of videos from last week you guys can look through if you don't understand something. Again, I can only try and give you the information. If you don't do it, nothing I can do for you, right? So a big part of this is doing. It's not watching, right? Watching is what we want to do. When I do something, I want you to follow along. I don't want you just to watch. I want you to do your stuff, get your hands dirty. Do the things you need to do, because that's the only way we learn how to be programmers. If we don't do that, It doesn't matter how much I give you. You in?
Here. Hit the stream.
There you go. You don't need to do that. Just skip. No, don't do that. On the bottom it says you don't have to sign. Just go next. Now see where it says development settings? Click on C#. That's right. Press start. So now this version of Visual Studio will always be for you starting as with the C#. Give it a chance to load up for the first time, and then you're good to go.
Can you change that setting from over here?
Yeah, you can change it later on. Don't worry about it. No. If it's not set up for C#, you can always pick other languages and choose C#, which is what we're going to be using, right? Is it dead for that one too?
No, it's good. Yeah, we're just waiting for following. Still pressing repeat button.
Yeah, leave it like that for now, and then what we'll do is we'll.
Once it starts project,
There we go. Okay, so go to New Project. You go File, New, or click New Project. Let's do the File, New route, like I'm doing. File, New. Okay. Project. Follow with me, guys. When I click Project, it takes you to this dialog box. That's what this is. This is a big dialog. That's what it's called, right? The dialog boxes have a bunch of different selections you can make. In Microsoft Windows, most of them have an X at the top right. The X means you'll close it and cancel. You don't want that, right? There's a bunch of, if you've chosen Visual Studio, you have an option for Visual Studio as your language right here, right? However, if it's something else, you want to choose some other language, and let's say it's not Visual Studio, somehow you chose VB or some other language by accident for your developer settings, you can always reset your developer settings, but for now, you can always choose other languages and click something else. Like for example, it'll come up under other languages for you, right? But for now, just choose Visual Studio, and then from there, on the right, you'll see a bunch of templates, right? In the .NET Framework 4.5. That's what we're using right now. So there's a bunch of these templates, and these templates are our starting point for creating our application, right? So we want to choose console application for now, and for a long time until you get to programming 2, it'll always be console application. So choose console application, and down here where it says the name, console application name, you're going to make it so that it's going to be COMP100. That's what I put in, and I put lesson 5, right? Lesson 5. Now, you don't have to do this, but I will. It says down here on my side, it'll say create Git repository. We talked about Git last time. For you, it might say add solution to source control or whatever down here. You can leave yours unchecked, right? For me, I'm going to put a check mark, because I want to create my Git repository for you guys, so you guys can always go to GitHub to take a look at my code, right, to see what I've done. Remember, that's another resource. So these are the resources you have. You've got the PowerPoints online on eCentennial. You can go up and see all those PowerPoints because I put them all up online, right? You've got GitHub. If you go on my GitHub link, you can see all of my GitHub code up there for your class, COMP100. And then you also have the videos, right, on YouTube, where you can go up and see kind of recorded, all of our classes being recorded. I can't do much more than that. Of course, there's attending class, too. That would be a good thing. Because if you don't attend class, that's like the worst thing. And you'll get behind, and there's nothing I can do for you, right? If you need to meet with me because you're not understanding something, right, don't wait till the last minute. Like today would be the last minute before we see each other again to kind of say, Tom, I don't understand, right? Sending me an email, I might be able to respond within 24 hours or so. I'm a busy guy, but the best thing for you guys to do, and I recommend this highly, is to instead of sending me a note saying I don't understand, say, can we meet? I'm available between 12:30 and 6:30 every Wednesday, right? So on Wednesdays, before we meet here, if you want to meet me a couple hours before we meet, we can get together, you and I, kind of one-on-one, and I can go on over with you stuff you don't get, all right? I'm also available other days. The only day I'm not available here physically is Thursdays. I'm in Georgian College in Barrie, so I will not be able to meet with you on Thursdays. But sometimes on Monday, especially on Monday morning, I could meet with you anytime between 8:30 and 12:30, as long as I have an appointment ahead of time. So you just can't just drop in and say, hey, I'm here, right? That doesn't work because I might be doing something else at that time, or I might be with somebody else, right? But as long as you let me know ahead of time that you want to meet with me on Monday morning, let's say, or on Wednesday after 12:30, we can kind of set something up, right? 12:30 or Wednesday would be kind of the easiest day for us to meet because I've got a long period, 12:30 to 6:30, 6 hours, where I can book time with you guys one-on-one. The place you'd meet me is A230, which is where you would sign up for changes, ads, all that kind of stuff. So you know where that is, and the main office there, right? A230. And you can always send me an email saying, Tom, I need to meet with you. Can we arrange a time frame, 1 hour, or whatever you need? And then I'll go over some basics with you again during that time if you have a problem. But my expectation is when you show up with some questions. You don't just say, I don't get it. I can't help you. That doesn't mean anything to me. What does that mean? I don't get it. What don't you get? Nothing? Have you looked at the videos? Have you read the PowerPoint slides? Have you tried some stuff on your own? What have you done? And that's what I'm going to ask you when you get together with me before you come together to say, I don't get it. I can't reteach you stuff again. That I won't do. But I will go over stuff if what I said to you doesn't click. And you show me stuff and you say, is this what you mean? Oh, no, it's not this, it's this. I'll correct you. But if you tell me I don't get it, and I haven't looked at the PowerPoints, and I haven't done your YouTube videos, and I haven't done the work, nothing I can do, right? So this is your piece, right? I'm not a religious guy generally, right? But I can tell you that God always says, "I'll meet you halfway," right? So I follow that kind of edict. I'll meet you halfway, but I won't do the work for you. All right, so let's take a look at this. So we're in this console application here. And COMP100-lesson 5 is what we're opening up. I'm going to click on this new Git repository. You're not. And I'm going to press OK. Okay, that's where we're at. It brings up, this is our editor window. Just a recap of what all this stuff is. Here is where we're going to do all our creation of our code, right? On the right-hand side, our Solution Explorer on the right-hand side shows us how the project is laid out. We have the solution, which is up here on this line. And then inside the solution, we can have multiple projects. Now, I've only ever asked you for one, and I'm only ever going to ask you for one. I'm not going to bundle multiple projects inside of a solution. Sometimes it can get a little bit confusing, and that's why I won't do that. I'll just put one in there at a time. Okay. So right now, I only have one. It's called COMP100 Lesson 5. That's what it's in there, right? I'm going to connect with GitHub. I'm going to go to Changes, and I'm going to say initial commits, right? I'm going to do a snapshot of my code right now, which is really nothing. There's nothing that I've done. I've just created a new project in Visual Studio. And I'm going to go to unsync commits, and here's where it's going to ask me for my GitHub URI, but I haven't created a holding space online and on the web. I haven't done that yet. So I'm going to do that. GitHub, this repo is what I'm going to create. I'm going to go to plus. I'm going to go new repository, right? And I'm going to say COMP100 lesson 5, right? So I've got lesson 3, lesson 4 there. The first time we met was lesson 3, and now this is lesson 5. It's going to give me, as long as I'm connected and GitHub responding nicely, it's going to give me this GitHub link. I'm going to go in here and plop it into this location, and when I publish, right? You want to check me out on GitHub, you can see what I'm seeing now. Okay, I've got a couple commits. And again, I'm available through github.com/Ciliopoulos, my last name. And if you go there, it looks like this, right? You look at repositories, and inside repositories, you'll see a bunch of them for different classes. Like today I did an Ajax demo, jQuery Mobile, when I was doing my COMP100 class. I've got COMP123, which is your programming 2, right? COMP1011 from another college, COMP2068, a bunch of different demos there for that college, and I even have other ones, right? So I'm going to keep doing this as we go. There's going to be more and more of these repositories, that you can go search. So if you want to search for a repository for today, you can go COMP100 and it'll give you all the repositories that I've done with you guys. So I've got 3. The day 1 repository that we got together, right? You can look at that and look at the code, right? So you can see what the code looks like. This is what it looks like. That's all we did on day 1, right? And then you can go back to day 2, right? So if I go COMP100, I want to search for that. Here's day 2, lesson 4, right? I can go in there 7 days ago exactly. I can go in there to lesson 4, take a look at my program. This is all the stuff we talked about last week, right? Input from the console, interpolation, how we use a read line. All this stuff is what we did last time, right? And then today, which doesn't have much of anything because we haven't done anything yet. Here's today, right? 2 minutes ago. And if you look at my program at this point, there's not much in it because we haven't started yet. Okay, so let's get going. I just wanted to show you that so you know where to get the information. And again, it's recorded in case you forget. Okay, another thing I have to look at. Let's take a look at this the structure for our project again. You're going to see a lot of stuff you don't understand. Who remembers what using statements do? Right? We haven't really talked too much about them. But what do they do? I kind of mentioned them before. Anybody? Take a shot.
What is it?
Just say something. Huh? You don't know?
What is it?
Using. Why do we have using statements? What are they?
I'm guessing because that's like the codes that's like the set of codes that we're gonna use, like not the actual code, but like the
Not really. Let's talk about this a little bit more. You're going to see these usings. Normally, for now, we just ignore them. Okay? But really what they are, they're like import statements. They import additional functionality into C# that isn't built in. That's what we do. Well, we can actually add them in. And the reason why you see these up top here and you don't see nothing, like instead of seeing nothing at all, is because C#, we try and make the language efficient, so we don't load libraries into the language that we don't use. We don't need them. C# is a very large library that has all kinds of libraries you can add in. Some of them are built in, some of them you have to add in, and most of the time, for all these are the system libraries with different collections, generics, all this kind of stuff, things that we won't talk about for a while, right? So literally, you could get rid of most of this stuff. We're not going to. My recommendation is just leave it as is. Don't touch them. But if I was going to look at what C# would look like, you know, just kind of as when we talked about scope, right? And we talk about variables, right? I'm going to draw some stuff out here for you guys like I'm drawing on the board, okay? So here's something we can think about. I'm going to represent scope as a bunch of boxes. So here's my first box, this big one. This big box represents all of C#. Let's imagine that. So I'm going to call this C#, right? So this is all the functions and everything else, right, that this box represents. I'm going to put C# on the outside just like this, right? And then that is our C# box. And that means that C# has everything that lives and breathes inside C#, the programming language, is in this box. Think of it like this. Very, very abstract, okay? Let's make some other little boxes really quickly. Okay, let's talk about namespace really quickly. You'll probably never need to use this from now until the end of programming 2, right? But we'll talk about it because you see it every time you create a project. You see namespace. Here's namespace, all right? The namespace, and I'm going to make another little thing for you, so you can always look this up on the video. Here's my namespace. Represents all the stuff in this box, right? The box underneath C#. Everything in the namespace, you know, every namespace can access stuff from the C# programming language. It includes all the libraries, all the building blocks to make our code, right? If I'm in here, if I'm accessing the C# programming language, it has built-in functions and things that we can access, right? Think about namespace as a folder. There could be many namespaces, right? Right now we have one. For you guys, our namespace is what we're calling it today. If I go back to today's project, our namespace is called COMP100 _ lesson 5. And it happens to be the same it looks the same as our project. So this is our project namespace right now. Even though we have this one namespace, which is like almost like a container for all of our work, we can have multiple namespaces. For now, that's all you need to think about. And we won't talk about namespace again. Like, not really. I won't test you on it. I just want you to understand what it is. So when we use our using statements, right, what we're saying is, let's go into the C# language, and there are additional features that we're not using right now that aren't included in our code. For example, there might be some classes that exist inside the C# language that are not immediately in our namespace, but we can call upon them, right? And we use the using statement inside our code. I'm just going to put this in there as, and we'll just erase that one. Try that again. Let's think about this as other, like libraries. Okay, we're going to call this libraries, right? There's a bunch of libraries that exist in the C# space, if you will. Here, put it over here like this, libraries. And it's a little bit small for my container. It doesn't matter, right? So here's our libraries. And inside this, we can call upon the libraries and bring them into our namespace, right? Okay. But immediately, they're not always part of our code because we don't need to use all of them because we want to keep our code as small as possible, right? So we use the using keyword to access those libraries and include them in our code, right? So right now, whether you like it or not, the basic project you launch with Visual Studio actually adds a lot of extra functionality that you don't need. Leave it the way it is for now. Don't touch it. It's not necessary. You're not going to break anything if you take some of it out, but you might break something if you take out the system namespace. Like you won't be able to do anything with the console if you do that. And we'll talk about that in a second, or the system library. Okay, inside our namespace, right, we're going to draw another little box. Inside our namespace, we have our program right here. Okay, so this is our program, and our program should be right now, if you just leave it the way it is, right from the get-go from C#, right, I'm just going to put this over here. Our program, right, and our program looks like this. This is our program. It's called class program. And this is inside of our namespace, which is inside of C#. So there's different containers. In our program, anytime there's a box, our variables live and die in that box, okay? So when we create our variables in this program, they only exist for this program. They don't exist for C#, the whole library. We'd have to create a new library to share with other users, right? This program, if I make a variable, the scope of the program in this level is available to anything in the program, okay? Think of it as a global variable. It's available everywhere, right? Typically, we don't do it that way. We want to try and make it so that variables have a limited scope. So they have a limited ability to be visible. Scope, when I say scope, I mean, can you see the variable? Can you use the variable inside these curly braces? Take a look at the curly braces, like I said before on the first day, as this opening and closing curly brace is almost like a container. There's another opening and closing curly brace, that's another container, that's a class. And then in here you have another one, this static void main method, that's what it's called, with this other gobbledygook, string args. Truthfully, you don't need this either. This is listening for any kind of additional arguments or parameters that you can get from the console, as if I was going to launch the program from the console. We're never going to do that in this course. So leave it as is. This is just how it looks, but you're never going to need it for now. All right? So this static void main is another layer, right? Here's the program, and if I was going to draw another little box, our static void main is right here, right? And we're going to call this, I'm going to label it. So here's, take a text block and make this main, right? And we're going to take main and put it in on top of this so you can see what it looks like, right? So this is main. So our main method is inside of our program, which is inside of our namespace, which is inside C#. Yeah? Okay. We're going to do all of our work for this course inside main or inside this program space. In order for us to have stuff additional libraries, I may have using statements, right? And I'm just going to make a little line. So here's our using statements. Let's say the using statements up here that we're going to call upon, right? I'm just going to go across and use the using statements to call more libraries to include them inside of our program. That's all I'm doing with using statements. For now, you don't need to know anything. You just need to know what they do. You don't need to know how to do it or why. Question?
Is using like taking out whatever program your computer can run in C#, or
It just includes additional libraries and functions. That's all it is that you don't use. It's in the background.
you can put your using and then you do that sketchbook. You can do that in C#.
If I go using, if I want to use using, if I want to include system or collections or whatever, I can include additional libraries. For example, if I go on the top here, I do some spaces and I start typing using, right? I can start typing. There's different libraries that I can include, right? And if you notice this open bracket and close bracket, these are some spaces, some namespaces or some libraries. Here's another one, MS, Microsoft. There's Microsoft, another big library, the Microsoft library. Here's another one. Here's COMP100, lesson 5. That's our, guess what that is, a namespace, right? So using is calling upon other namespaces, other folders that exist within C#. Let's take a look at Microsoft. So I'm going to use Microsoft, right? And I click dot because everything we access is with the with the dot accessor, dot notation, right? I can access Visual Basic or Win32 or SQL Server or Runtime, other libraries. So let's go C#, C# library, and inside there I want to get the runtime binder and so on. I can ask for additional functionality here. I can also use different pieces of the system library. System is a big library, right? It includes data, deployment, diagnostics, drawing, dynamic, all kinds of other stuff. Web, UI, tons and tons of stuff, right? I'm guessing there's probably a Windows library too, right? Or something like that, Microsoft. And then if I go Win32, that's Windows. And then I can, take a look at other things that it includes, right? So all kinds of other libraries. Right now you have all the libraries you need and will ever need for now and for programming too. Okay, so leave these as is. Don't touch them. Okay, so we're inside of our void main. I know that's a little bit of we kind of departed from what we were talking about today. But I want to talk about it so you understand. You're not afraid of what all this stuff is. All right? Okay, so now inside here, this is where you're going to write all your code. So I'm just going to put that in there. Your code goes here, right? This is where your code is going to be written for now until the end of this course, in here, between these two braces. Okay? If you want to pass and if you want to know what you're doing, you got to write your code in here. Okay? So what are we going to do? When we do console commands, when we do set up array, variables and so on, we do them in here, inside the main method, right? So this is where we write our variables. And remember, let's write a couple variables here. And one of them is going to be a string variable we're going to call prompt. So string prompt. Okay, prompt is just a name where we're going to hold our input from the console. All right, string prompt, right? And when we declare it, I first declare the data type, which is string, prompt, which is the friendly name for the memory location for the string. Okay. All right, cool. Now I want to get the prompt. I want to get the prompt from the console. I'm going to say prompt is equal to console.writeLine or .readLine, sorry, .readLine, and we're going to read a line from the console. Right? That's cool. That's okay, right? But I think what we need to do is prompt the user, ask the user for input. So we're going to do a console.writeLine to kind of go to the console and say, or maybe if I do a console.write, what's the difference between a console.write and a console.writeLine? Don't do it for him. Let him do it himself, please. Okay? He's not going to learn anything if you do it for him. Okay? I need you to type. When I'm telling you to type, or else you're not going to learn. Right? So if I go console.write, what's the difference between console.write and console.writeLine?
I was just about to ask you what's the difference.
Huh?
Write sound like on the same line.
Yes. And WriteLine adds a new line character. Right? So it actually goes to the next line. That's what it does. So if I want to rewrite something and read something from the same line, I'm going to use console.write with a read line. Okay, so this is what I'm going to put in here. I'm going to go console.write, please enter your name, right? So this is what it's going to kind of type in here. And then our prompt is going to enter the name, is going to hold the name. It's going to read your name from the console and hold it inside this prompt variable, right here. Okay, okay, that's what the first thing it's going to do. Then I want to spit your name back out again, right? So I'm going to say console.writeLine, right? Your name is, this is almost like part one of the assignment, right? Your name is, and I'm going to use a string interpolation, but this is a placeholder where I kind of put in the name of what your prompt is, right? Here's my prompt. This is what I entered, right? Your name is, and then whatever prompt. Prompt is just a holder for your string. I could change this to make it something else if it makes more sense to you. But when we say get a prompt from the user, it means just have some kind of, you're asking the user for information and you're going to hold it inside a variable, right? Okay, cool. So I'm going to spit this back out. Now we're not going to see it because remember, when we kick off Visual Studio and we try and prompt something else, it's going to go boop, boop. As soon as we put it in, it's going to flash and it's going to be gone. Let me give you an example of that. I'm going to run it. When I start, it's going to say, please enter your name. I'm going to say my name is Tom, and then it's going to be gone. Why? Because we need to do a read key. Remember, just to read what it is. So I'm going to do that on the bottom here. I'm going to go console.writeLine. I'm going to say, please, or press any key to exit. Okay? Just a nice friendly user message that says, hey, this will allow us to hold the console open, and we'll read key. We'll use read key as a way of holding the console open. So it's going to wait for a key, any key, to be pressed, and when you press the key, it's going to close the console. That's what it does. Okay, that's cool. Let's run that really quickly. This is just a review from last week. Here it is. Please enter your name. I put Tom. Your name is Tom. And then press any key to exit. I press any key. Boom, it closes. Okay? Let's do a couple of things though. I'll say this to you now, and you'll probably hear, if you have me in programming 2, you'll hear me about saying the same thing in programming 2. Consoles.writeLine don't cost you anything, eh? They don't cost 25 cents. They're free. It means you can use a bunch of them to make your code look nice, right? Your output. So let's take a look at this. So your name is, let's add a couple of other console.writelines. So console.writeLine. Okay, you know what? I'm going to add in a bunch of these pluses just to make it look, like a separator, right? And I like this plus, so before I do that, I'm going to copy and paste it down here as well. Okay, so that's what your output is going to look like right now. And you know what? I want another console.writeLine. And the console.writeLine is going to be empty. What does the empty console.writeLine do? Just gives you another space down, just spaces down one, right? And then the same thing, we're going to do a console.writeLine, so we're going to kind of give a space between your output up here. So what am I doing? I'm just formatting the way it's going to look when I get input and output. Okay, here we are. And I'm going to run it. Let's take a look really quickly. All right, I got enter your name. It's hard to see. So let me just change my properties. You don't have to do this. I'm just doing it for you guys. I'll make my screen white and my text black. Reverse how it looks. I'm going to go to font. I'm going to click Consolas 20. Press OK. It's like huge now. Take a look. So please enter your name. I'm going to say my name is Tom. And it says your name is Tom. Press any key to exit. That's like, you know what? That's like part 1 from your assignment 1. Done. But instead of printing, one character, I'm entering a whole name, right? Okay, cool. So this is part 1. I'm not telling you how to do your assignment number 1. I'm showing you piece parts of how you could use what I'm telling you. I'm showing you some code, very simple code that you can use in your own assignment. Okay? Okay, so this is cool. That's what you need to know how to do. The other thing is, okay, I've got some input, but now I want to store a number into my my code. This just stores string, which is it's text, right? I want to convert my text string into an integer, And the way I do that is I need to use a method to do that, right? So let's store another number. I'm going to kind of create an integer, and I'm going to call this number, right? And you know what? Let's make it so that's realistic. I'll put in age, right? Here's your age. It's an integer this time, though. Okay? If I say, please enter your name, and now I'm going to go down here and I'm going to do the same thing. Console.write, right? Please enter your age, right? Okay, here we go. And I'll also accept it into the same prompt. Now, this is some interesting stuff I can do here. Here's my read line, right? Okay, I'm going to give you some space. Remember, white space is ignored by the compiler. It doesn't care about all these extra spaces. It's just for me, for my viewing pleasure, right? It's for me, so when I look at it, I'm like, okay, I get what it is, right? I can separate. It makes it easier for me to read the code, right? The computer doesn't care. All right, so this is console.write. Enter your name, enter your age. I'm still getting a prompt for my age, and I can say your name is prompt. But you know what? I don't want to store my name in the prompt, right? I want to store my name in another string, right, called name, right? And you know what? I want to store my age in an integer named age, right? Because that makes sense. So when I get the prompt here, I'm going to do one of these. I'm going to say, actually, you tell me what I could do. If I want to store my prompt in the name, what do I do? Yes?
You add the string to the console.read line, or you add it to the prompt.
The string, what string?
You add the, for the name.
I want to put my prompt.
So you add the string name into the prompt.
No,
read line.
that's not what I do.
What's your question?
I want to take the value that I get from my console, which is right now it's in prompt, and I want to put it into name. What do I do?
You do like name is equals to console read line, or do you want to?
I already did that. I did that with my prompt, right? Prompt already has my name.
You could do name is equals to string something.
How about you? You have another solution? You're making your code right now. Think about this as your code. You're writing, right? What would you do? If I want to make the stuff that's stored in prompt, which is my name right now, right? I want to take this and put it inside another location. What can I do? I need to use an assignment operator. I need to use equals for sure, right? I already have it in prompt, so I'm not going to do this again, right? I've already done it one time. I don't want to prompt the user for another input. I already have his input. Here, it's stored in prompt. So what do I need to do to name?
Name is equals to.
That's a comparison. Name equal compares name and something else. I want to make an assignment. What's an assignment? 1 equals.
Do you put it in the brackets after the read line?
No.
No.
I do this. I say name is equal to prompt. I take the value that I get from prompt and I assign it into name. They're both strings. So I know it's simple, but you got to think this through, right? I take the prompt and I kind of flush it into name right now, right? I kind of make it equal right now. When I do this, they're not the same thing. Prompt and name are different variables. They're different memory locations. All I'm doing is I'm saying take the value that's inside prompt and assign it to name. Take that value. An equivalent of that, I'm going to kill this for a second. Let's think of it, and this is sometimes people don't understand, so I'm going to kind of draw it out again for you. I've got 2 memory locations. Okay, here's one, and here's the other memory location. All right, there's 2 memory locations. I'm drawing this on the board for you equivalently, right? And I'm going to put a number to this memory location. So I'm going to call one memory location 1000. Okay, here's memory location 1000. Do you know that it's memory location 1000? Absolutely not. You have no clue how the computer is going to choose the memory locations. I'm going to choose another random memory location called 1023. Okay, just random. Okay, doesn't mean anything to you. Okay, this is what maybe the computer is numbering them like this. Here's my first memory location. Here's my second memory location. They're like 2 boxes, all right, or 2 buckets, if you will, right? Hold on. Now I named them, all right? So I'm going to call one of my memory locations I'm going to call one memory location prompt. Okay? That's what it's called. That's the friendly name for my memory location. All right? And I'm going to call the second memory location, right, name. That's a friendly name for this memory location. Okay, cool. I like that. The value in prompt, right? I go to the console and I get a value. I enter a value, and the value that the user enters is Tom, right? Or whatever your name is, right? And it sits inside that memory location. And now what I want to do is I want to make a copy. I want to copy whatever inside this memory location 1000, which the friendly name of prompt, by the way, 1000 is just a random number. I chose out of my head. It's probably not 1000. It's probably like 1E3B47500, big long string of characters. Okay, you don't know what it really is. I want to take this and I'm going to copy it in here. And the only way I can do that, right? And I'm just going to kind of copy this out. So I'm going to go to this, right? I'm going to cut this. That's not what I wanted to do. It's not what I wanted to do. These programs. What I want to do, okay, let's just highlight the whole thing here. What I want to do is take this whole thing here, right? I want to cut it and see if I can actually do this. I cannot. Copy merge, sure. And I want to paste it. That didn't do it either. Just undo. Deselect all. What I want to do is basically say, hey, you know what? This stuff here, I want it to equal this. How do I do that? I use the equals operator. I've just put them in the wrong order. Right there, this should be on this side when you see it, right? Name is equal to prompt, right? If I go name is equal to prompt, name is equal to prompt. What I'm doing, right, when I do that, is I say, take the value of name or prompt and put it inside here, right? And now what happens is Tom sits inside this new variable right here. Okay? It doesn't go away from here, right? It doesn't get reassigned. Both memory locations, 1000 and 1023 in this case, or prompt and name, right? These two variables both hold the same value.
So it's like making a relationship in database.
Yes, it could be seen this that way, but the better way to think about it is just two buckets. I've got two containers, right? I've got prompt and name. I've just named them. And I'm saying, hey, use prompt and fill it up with the input that I get from the console. Okay, that's what I'm doing. Fill it up with that input. Okay, cool. I got the input. My name, the characters are Tom. That's good. Now I want to take it and copy it into, pour it into the other one, but keep a copy over here. I'm not deleting this one, right? I'm keeping this original copy, but I'm making a copy into the other variable. So if that's true, this is what I'm doing. I'm saying name is equal to prompt. I'm using an assignment operator to take the value of prompt and put it into name. Get it? Okay, cool. But this won't work now. Look, down here, this console.writeLine, where I print prompt out, that'll surely work now. But I'm going to do it again, except this time when I ask your age, I'm also going to put it into prompt. Here, look, here's my age. But remember, age to me is an integer. Take a look, because you're going to miss it. So here I'm kind of putting, I want to put prompt, this new value, whatever I'm getting, into the integer value, right? But I can't do this. Age is equal to prompt. Why can't I do that? Why does C# give me an error?
Because they have a different, using an int and string.
Good. The different data types is what it's called, right? Because they have a different data type, they can't be, that you can't make one, you can't assign one to the other. You can't assign the value that's held in prompt and put it into the value of, the placeholder for age. You can't, because there's two different data types. One's a string of characters and one's a number. They're not the same, right? It's like saying, how many apples are in every orange? Huh? The compiler's going to say, I don't understand. What do you mean? Right? So what I need to do, I need to convert it before I do that. I got to say, I want to convert prompt, right, into an integer. And the way to do that is, there's a couple ways, right? I'm going to put it down here. We're going to learn this. I can use something called convert, right? I can go convert dot, and I can make it 2int32, which is what I want to do. This is the actual method, right? And I can put in there prompt, right? Because that's what's going to be converted, right? So I can convert prompt to int32, right? And what this does is it returns, it makes it into age. So I can say age is equal to convert to int32 the value of prompt. I'm using a method to do that. And you can use convert to whatever you want. Like if I want to convert to float, or convert an array, a string to something else, yeah?
So prompt will be string and integer at the same time?
No. Prompt can only ever be a string, right? I've already cast it as a string up here, right? But what I'm doing is I'm converting the output, the value of prompt, not forever, just temporarily, right? Converting it to an integer and moving it into age. So even though, let's go back to our example, right? So even though I've got a couple of buckets, okay, let's look at the bucket example again. This is very important for you to understand. I've got a couple of these memory locations, right? Here they are. And one of them over here, right? One of them over here, this one is called prompt, right? Okay, right now. Here it is. This is prompt. It's just the friendly name for this memory location, or this container, if you will, right? This bucket, this cup, whatever you want to say, full of, that we're going to fill this up. And in there, instead of putting a name now, I put an age. I'm going to put the number, right? Here's a number for the age, right? So, but this number isn't really a number. This number, when I get it from the console, is always this. That's what I really get. I get a string, 2 characters, 4 and 5. It looks like a number to us, but the computer doesn't see that. The computer sees 2 characters, the number 4 next to the number 5. That's how it sees it. So you can't take 4 and 5, these 2 characters, and think that it means 45. The only way you can do that is to use a conversion method that I just showed you, convert to int32, right? And then what we want to do is we want to convert this. So here's another one. I'm just going to go back to this piece here. So I'm going to say, here's my age. This is the variable age. But the age variable is an integer, right? It needs to take 45, the actual number, not in quotations, 2 characters, 4 and 5. They're just characters. They're not numbers, right? It's a very interesting distinction. Here's the real number, 45. That's a number, right? And you can do things with a number. In order for you to do that, you've got to convert. And again, this is just for your pleasure. So when you look at the video and you remember when you remember this conversation we're having, that's what we're doing. We need to convert one to the other, right? So that's what I need to do. I need to convert one of them, and I need to take this one, the number from here, when I convert this one, use a conversion method, and then plop it back in here. Make sense? I can't just accept my prompt as 45 because it's not 45. It's the character number 4 and the character 5. It means nothing to the computer when it's a string. And any input you get from the console, let me take it further. Any input you get from any place, that's a number that the actual person enters, unless it's like a button that you press online somewhere, right? It's always a string. Always. And you always have to do a conversion. What does this mean? What if I entered A in here instead and I tried to convert it into an integer? Would it work? What would happen? It's going to break the program is what it's going to do. Let's see that happen. All right, so here it is. I'm going to convert it here. Now, I've got name here, and I want to say your name is, but prompt has been overwritten with age. So I can't use prompt anymore. I got to put age in, name in here, right? Because my name is name, whatever the value is. And you know what? I'm going to do the same thing. I'm going to do my name and my age, right? And your age is age. Okay, here's my name, here's my age. Okay, so let's try this out for a second, and let's add some normal values where, you know, I'm not going to mess the computer up. So my name is Tom, and my age is 45. Your name is Tom, your age is 45, press any key to continue. That's great. I entered all the nice things, but I'm not a nice user, and I want to break the computer. So now I'm going to make something else put in there. I'm going to say my name is Tom, I can put, and my name is Tom, blah, blah, blah. Okay, cool. And my age is A, right? What does it do? Bam! It breaks the computer. Actually, the string didn't break the computer. The A, instead of a number, broke the computer. Broke the program is what it did. And if you notice, it kind of goes right in here. It tells you, the debugger basically says, hey, this is a stop. This is where your issue is, right here. And if I hover over stuff when I want to see the value of things, if I look at prompt, right, the value of prompt, see what it says? The debugger, it says prompt is A. That's not right. I'm listening for an integer. How can I have A as an integer? That's ridiculous, right? I can't convert it. This is where I have a problem. It's going, I can't convert a string into an integer. Come on, guy. What are you doing to me, right? And here's another one, right? Here's my name, my prompt. I got this long list of characters here that's in my name. Blah, 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 blah. This worked. This wasn't going to break my code. Because it can take a big, long string of characters. Eventually, it'll break. Yeah.
Is it possible to put a constraint on the age so that you can't put a
Yes, but we're not going to do that right now. Don't worry about that right now. For your assignment, you're going way, way ahead. Think about right now, when I ask you for assignment number 1, all the little inputs, think about the user entering perfect inputs,
Okay.
not trying to break your code. I'm not asking you to test your code so it's unbreakable. No. It's like that's way ahead for now. Think about ways, you're going to need if statements for that. We're not at that point. We're not even talking if statements yet, right? So think about entering your data and it's entered perfectly and you're spitting it back out again. Okay. I'm going to save this. I'm going to stop debugging, right? With Shift F5, you can do that. Stop debugging, and then I'll stop here. And from here, I'm going to go into my Team Explorer and I'm going to update this stuff to GitHub so you can always see it. So, basic example of console input and output. Right? Input and output. Okay, cool. And I want to go to unsync commits and sync. Okay. Anyone have any issues understanding variables? Variables are friendly, names for memory locations or containers to hold your data. That's what they are, right? When we declare your variables, you declare them up here. There's different types of variables. Integer, floats, decimals, all that kind of stuff. One of the common ones you're going to see is string. And if you think about what prompt is, it's just a placeholder. It's almost like a temporary location where I'm going to hold my string, then convert it or assign it first to name, and then convert it here to when I convert it to integer. Okay. By the way, I can take all kinds of input, right? Like for example, let's do another one. Okay, I want to have, a Boolean, right? I'm going to say, happy, right? Happy is like a yes or no question, right? Are you happy? Yes or no. Are you happy? True or false? True or false is a Boolean, right? Well, guess what? I can prompt. I'll do this. I'll just copy all this stuff again, right? Here, I'm going to prompt if the person is happy. I'm going to say, and just to be smart, I'm going to put in, the name of the person, right? So I'm going to say the name of the person as a placeholder, right? That's my first placeholder, comma, are you happy? And then in kind of just to tell the person what I'm looking for, I want to say true, right, or false, right? True or false? Are you happy? Right? So I want to get the prompt. I'm going to use the prompt again. And by the way, when it says name, my console, it's just a right line. I'm going to say name, right? So this name is going to substitute itself up here. Name, whatever the name is of the person they entered. Are you happy? True or false? Right? It's going to read everything from a read line perspective, put it in this temporary location, holding location called prompt, and then I need to say happy, but I want to make it a Boolean value. I want to hold that true or false, and I can't do a convert to into 32, right? I need to do another type of conversion. Let's just kill this for a second. Move this prompt aside. I want to say convert to, right? And if I look at Boolean, there it is. There's a convert to Boolean, right? To Boolean, which converts my prompt into a real true or false, right? So now happy is, you know, if I'm happy or not, true or false, right? I want to print that out. So I'm going to go down here and I'm going to kind of copy and paste, you know, say something like, you said you are, you know, so, comma, you are, and then here's the string interpolation again, comma, and we'll use the Canadian, eh? So you're happy, eh? Or so you're sad, eh? All we're doing is getting some input. Here's happy, right? Happy, yes or no, true or false. And so you are happy? Could be happy or yes or no, right? Let's try this out, see what the output's going to be. All I'm doing is adding just inputs, right? Tom, what's your name? Tom. My age is 45. Are you happy? True. Okay. Your name is Tom. Your age is 45, so you are true, eh? Hold on. I didn't ask that. I said I'm happy, right? So this is wrong. I set this up wrong. So we'll say, so it is true or false that you are happy, eh? It is true or false that you are happy, eh? Make sense? Now that makes sense as a sentence. Let's try that out. Tom, 45, true. So it is true that you are happy, eh? Right? If I put it, try it again, right? Put other values in there. Mark, 30, false. So it is false that you are happy, eh? That still kind of doesn't make sense, true or false, right? But at least it's kind of syntactically correct. But the idea here is it can take a Boolean value, you know, true or false, you know, as an example, and kind of retain the value, right? So true or false is Booleans. That covers one of your sections, right? And what about floats? I want to add two floats together, right? So two things. And let's say we want to say, you know, how much money do you have? You know, as we talked about money last week, right? And I want to kind of take an input for, you know, from the console. So I'll say something like, how much money do you have? Right, so I'll add that in. So I'll go Tom, again, Tom, how much money do you have? How much money do you have? Okay, and maybe we can put a value to it, whatever it is. I'm going to read it. Now this time, it's money, right? So I got to convert it. I got to convert it out to, instead of it being, I'm going to call it money. Here's another variable I'm going to name up here. Take a look. I'm going to call this float money, right? Money. And down here, instead of happy, I'm going to convert money. Take a look. Here's my money is equal to convert to float, if I can, right? Convert to, come on. I can't convert to float. I can go to decimal or double, right? These are the different values I have to convert to. String to UI32, decimal or double, right? Let's do a double to make it easy, right? Double precision. To double. And you know what? My input, my prompt. So I'm going to take my prompt and convert it to double. Okay, I can't make it this float then. This has got to be double, right? Okay, cool. So my money is double precision, right? I take my input from the console and I convert it here. Now I got to spit it out. All right. So I say okay. You said you have. Okay, and now this is where we can convert it. So we're going to say, here's our place value, right? Here's our place value, and remember we want to use the C, right? The C means currency, right? So I want to do something like this. C for currency. Remember this conversion? And I'll put in here money. If that's right, if I've done this correctly, and if I haven't forgotten something or made a mistake, if I run it without errors, it's going to say Tom, my name is Tom, name is 45, yes, I'm happy, and I have 10 bucks. Right? Said you have 10 bucks. If I don't do that, if I do it again, let's try running that again. My name is Mark, my age is 30, oh, my age is 0. I just got born. I made a mistake. I can't go back, right? I'm not happy because you know what? I have $0. Converts it. You know, take that in. So remember, even if you make false inputs, it'll work. This is why you have to test your code out again and again. My name is John. I'm 24. I'm happy. And John, how much money do you have? I have $100. It converts whatever I say to 100, even if I don't put it in as 100, right? Okay, good. You said you had 100 bucks. I'm going to add up. I'm going to give him money. I want to give him some money, right? So here's, you said you had some money, right? I want to give him some more money, right? I want to put in some, money from the kitty. I got some money that I've got stored away. I want to say savings, right? Here's some savings, right? And I'll make it a double as well. My savings is equal to, let's say 50 bucks. But I can't store savings like this, right? I got to put a D after it to specify that it's a double. So my savings is 50 bucks. Here it is, right? And now what I want to do is I want to take my savings and add it to your money, right? So I'm going to say, and of course, here's the result. I want to store the result. I'm going to put another variable, double result, right? Right now it's nothing. A bunch of memory locations I'm storing right now, right? And what I want to do with it is I want to say, here's some calculations. You want to do some calculations. I got money. It's been converted from the prompt into a double, right? It's been stored in the money variable. And now I want to add my savings to it. So I want to say result is equal to money plus savings, right? And let's not call it result because result doesn't make any sense. We'll call it gift. Okay, gift. Gift is equal to money plus my savings, right? That's what it's going to be. And I'm going to say this, console.writeLine. Here, I'll space it up so you can see what I'm going to write here. Make you laugh. Here, take, right? 0 with C means currency. That's what it means. It's placeholder with currency, right? Take, and my savings is what I want to put in here. Right? Take my savings, comma, the savings. That should help. Right? That should help. Here's my savings. And here's another console.write line. I'm just going to make some more stuff here. I'm writing all kinds of stuff today, man. I'm on fire. Console.write line. Now, oh, let's make, sorry. Let's say, add in a couple of space now. Right, console.write line. Now you have 0C for currency, comma, or maybe period. Have a great day, right? And of course we got to put in there our gift, right? Total value of our gift, which is your money plus my savings. We can also call this total money or sum. Maybe we'll call it sum instead of gift because I don't like gift. It's an ugly thing. Hey, I want to refactor, but I want to change all of the variable names all at once. I don't want to go through my code. There's a fast, quick way to do it. I'm going to click on, here, take a look at this up here. I'm going to click on my gift. I'm going to right click. I'm going to go to refactor and rename, right? If I rename instead of gift, it tells me what do I want to do. I want to change this, right, to sum, S-U-M, right? And I press OK. Once I do that, it tells me all the places where it's going to change the value. Sum, right? Also a couple places down here, right? That's where it's going to change the value. I'm going to press apply, and boom, it's changed here, here, and down here in one stroke. So I don't have to do it manually like I've been doing. Okay, cool. Let me run it and see what happens. Enter your name, Mike, right? Enter your age, right? I'm 16. And are you happy? No. I haven't gone on vacation for a long time. How much money do you have? $10. Right? Well, your name is Mike, your age is 16, so it is false that you are happy, eh? You said you have $10. Here, take $50. That should help. Now you have $60. Have a great day. Right?
You should add, are you happy now?
I could, right? But my point is that this is all the stuff, almost all the stuff that you'd probably be asked for on your assignment, number one. I just put it all together into one, right? So take a look. The piece parts of what I'm doing here in this example is probably all the pieces that you need to put things together in your assignment number one with some work. And you got to do some tests. Focus on one piece at a time. Assignment number one has 5 little assignments that you're going to do. I'm going to kind of stop debugging here, right? And I'm going to go up to my Team Explorer, and I'm going to kind of put this on GitHub for you guys so you can always have it. So added more examples, right? Commit, home, unsync commits, sync. Okay, now if I look on GitHub and I refresh and I go into COMP100 lesson 5 and I look at program, these are all the things we just did. They're all up on GitHub. You don't have to record it. I want you to try it. I want you to try doing this stuff. So it's there. So even if you can't remember how to do this, you watch the video, you go on my GitHub account, which is Tsiliopoulos. So github.com/Tsiliopoulos, right? That's my last name. And you look up COMP100 lesson 5, you'll have everything you need here. All your code is recorded here. You'll always have it. And by the way, when you do your test, you'll have access to GitHub, right? You'll have access to the PowerPoint slides. I give you access to that, no problem. You'll have access to your assignments, right? Anything you do an assignment, you'll have access to when you do your test, right? You will not have access to each other's work. It's independent, so you're going to do your test on your own, obviously, right? You won't have access to Google. That will stop. You want to be able to go, Google, how do I do this? No, right? You should know how to do it already. And I'm going to go around, I'll check you to make sure you're not doing that. So you have access to all those things. Part of your test, I'll tell you in advance, is going to be multiple choice, which I've already given you a bunch of stuff over the last couple of days. I'll give you some more today, some more multiple choice questions, right? And true and false. And then part of it's going to be practical, where I ask you to do something like assignment number 1 or assignment number 2. Little problems, a couple little problems. Huh? I could, but you can get it on GitHub.
Yeah, I know. But
No.
saying on the actual.
Yeah, get it on GitHub. Right? So all I'm doing here again is I've declared a bunch of variables. Here are the variables. And I'm taking different console.writes and console.readlines and entering data from the console into the prompt temporary variable over and over again. Right? Here it is. Here's prompt. I've overwritten prompt again. I've overwritten prompt again. And here's again. So what I'm doing actually, if I go back over here, here's my prompt, right? I overwrite it. I go, I overwrite this prompt. And now I'm going to take the value of prompt again, right? Here's prompt now. And I'm going to put in something else. I'm going to put in, you know, another thing. So instead of 45, I'm going to put in true, right? That's the second thing I'm doing, right? I'm going to take in true and put it inside prompt, right? But true can't go into age, right? True can only fit into that Boolean, which we called happy, right? So here's, I'm going to go back over here to happy, right? Here it is. And we're just going to say happy. Right, here it is. And I'll take this and put it inside there, right? This is happy, this is what this is. And I'm going to take this, convert it again, right? That's what I'm doing. Take it and convert it, right? I convert it and take it back in to this variable. That's what I'm doing. I'm converting it and taking it in there, and then from true, this isn't really true, remember? This is actually like this, true. It's a string that looks like true, right? This is what it really looks like, right? But what I really want is for it to be like this, with a capital T. Because true and false, a Boolean variable is true and false with a capital T, and it can store in happy, which is Boolean, true, false. Right? So the only way to do that is to convert it. Go through, I get stuff from the prompt, I store things temporarily here, convert it, and store it back into something else. So I'm taking one container, converting it, the value of whatever in there, and plopping it into another container. And I'm doing that over and over again. I've done that for this name. I did it for age. Name, there's no conversion because name and prompt are both strings. No, I just do an assignment, a straight assignment here, right? Age, I convert to int32 because age is an int, right? Boolean, I've made happy is a Boolean and prompt's a string. I convert it, right? And the same thing goes with money. Money is actually a double. I take my prompt, I convert it to double, store it into money, and then I do a little calculation. Sum is equal to money plus savings, and I output it with this formatting string. It's down here. So even though this is a placeholder right here, I actually use the C to output money, the $. So when I actually kind of go to do it, I'll say, you know, Lenin. I like that name. That's a great name, right? And I go in there and I say, Lenin, he's 20, right? Just guessing, right? And let's say, you know, he's happy. He always looks happy, right? And how much money do you have? He's got, you know, $10,000, right? Right? Because he's a rich guy, right? Well, hey, that's I'm gonna give you $50 more because that's my gift, right? Have a great day. But you see that it has the $sign value here, dollar, 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 and I did that by using this C right here, right? Make sense? That's how I do the placeholder, right? I use this format. If I just want the value with no formatting, it's this. If I want the value with a little bit of formatting, I put this. And there's different ways of formatting the data, like I showed you in the PowerPoint presentation, right? That shows you here how to do it, how to convert from one to the other. Let me see where that is. Here it is, right here. Formatting. Okay, here it is. Take a look. So here's C for currency, D for decimal, E for scientific, F for fixed point, right? G for general, and so on. Percent is a big one, right? There's going to be a question in there for percent, right? You want to calculate the percent, use P. And that'll actually show the percent sign in there. Okay, any questions around this? I know there are questions around this for sure, guaranteed, because you need to do this in order for you to understand it. If you just watch me and you don't do it, you'll never understand it, ever. Yes?
Instead of always going and getting the information from a prompt and then converting it, can I just add it in right away?
No,
There's no way to do it?
no. You need to convert it from string into another data type. Always. Always and forever.
Oh, I mean, you know, not that. I mean, can you create a string called age and create a, that's what I did. I created a string called age and name.
Yes.
And without using
But then you still have to convert it if you want to have some
Yeah,
kind
you
of
can.
calculations. Right? Yes, you could do it that way too. Instead of having a placeholder like prompt, you can make a bunch of strings. Name, age, blah, blah. Make them all strings if you want, right? But at the end of the day, if you want to do a calculation, you got to convert it. You got to use some kind of conversion method, right? It's just the way we program. The solution, your solution might be different than mine, but the result might be the same, right? Let's take a look at this. We can also use this substring method, right? Substring method. This is something new, right? I have a string, water, W-A-T-E-R. It's held inside the string, right, with position 0, 1, 2, 3, 4. Whenever we count memory locations in C# or in C-based languages, we always start with 0. We don't start with 1, okay? When I count memory locations, I start with 0. It's called 0-based indexing, all right? You're going to hear this, if you're a programmer, for the rest of your life. 0-based indexing we're going to use. And once you learn this, it's going to be the same when you do this, C++, JavaScript, many other languages, PHP. They're all used the same because they're all C-style, C-influenced languages. They all use 0-based indexing, right? So we start counting at 0. 0, 1, 2, 3, 4. So the 0th location then, 0th position would be the W, right? The first position would be the A. The second position would be the T, and so on, right? So if I want to get, when I use the substring method, it gives me between the 0 and there's two parameters it takes, right? The substring method takes where you want to start counting from, where you want to start looking at, and then the maximum value, the length of the how many characters you want to look at. So here's the start position, and here's the length of the string, right? So an example is if I start at water and I only count 1, I only take the W in this first example. If I want to take W and A, my length has to be 2, right? W, start at 0. This is what this substring is saying. Start at 0, 0. Start counting, and I want count for 2. 0, so it's 1, 2. The 0th position and the first position. Hear my words. The 0th, that's the way we say it. 0th position, or 0th index, right? 0-based counting, 0-based indexing. Okay, here's another example. 1 and 2, right? We want to start at 1, at the first position, position 1, and we want to count for 2. So A, T, 1, 2. That's why this is AT. And so on. Okay, so we can use the substring method to take a string and divide it into substrings, shorter strings, right? A good example of that is if I wanted to take, I wanted to look at a string and chop it up for some reason. Like take the value of, I want to count the first 4 characters of every name, because I want to create an employee number for you. All right, a special employee number that includes your name, right, or your last name. So I want to use, your first name, your first initial, and your last initial, followed by your age, right? Let's say I want to do one of those. Okay, let's do that. I'll make a new program to do this now. So I've got a bunch of this stuff, right? This is a bunch of stuff I've done here, right? I'm going to create a brand new program. So I'm going to go File, Close, Solution. I'm going to go File, New, Project, right? And I'm going to do a new console application. Follow me, guys, right? And inside here, I want to create a new thing. I want to call it COMP100, and I want to say Lesson 5, Part 2. Make it really long, solution. I'm going to add it to my Git repository. I'm going to create a GitHub account, a GitHub repository here. Go to new repository, and I say COMP100 lesson 5 part 2, right? Create my repository, take this URI, go back here, go to my Team Explorer, go to Changes, put an initial commit, right? Hit the commit button, go to Home, go to Unsync Commits. You don't have to remember any of this stuff, and go to Publish. When I do that, oops, that's not what I wanted. I don't go here when I do that. When I do that, if I want to refresh my GitHub repo, it's part 2 is ready to go. I can add stuff in. For now, what I'm going to do though is I'm going to pause this movie before we go into this second example.